Okay, welcome back. In today's session, we are going to solve three problems in control system. The topic is Ruth Hurwitz's criteria. So, the first problem is the characteristic equation of a control system is 4s power 4 plus 9s cube plus 6 s square plus 12s plus 1. So, we have to find the which option suits its problem. So coming to the solution, so the solution to the first problem is the characteristic equation. So given polynomial is 4s power 4 plus 9s cube plus 6s square plus 12s plus 1. So applying the roots table, s power 4, s power 3, s power 2, s power 1, s power 0. So for this one, we are putting the elements, that is coefficients of the polynomial. So 4, 6, 1. And for s power 3, 9, 12, 0. And for s square, just cross multiply. So 6 into 9 minus 4 into 12 divided by 9. Then for the next coefficient, 9 into 1 minus 0 into 4 by 9. We have to multiply 9 into 1 minus 4 into 0 divided by this coefficient. So that is the element for this row, and the third element is 0 in this row. So coming to the s power 1, the solution is, so by simplifying this we will be getting 2 by 3, and by simplifying this we will be getting the answer as 1. So from this we are going to find the coefficient for s, that is 2 by 3 into 12 minus 9 into 1 divided by 2 by 3. So by solving this we will be getting minus 3 by 2. So try to find by yourself, and this element will become 0, that is the second element in the fourth row, and this is be 0. And coming to the last one, constant, which is 1. So the 1 is the element in the last rows. So other elements are zeros. So if we see, just concentrate on the first column alone. So the first column elements are 4, 9, 2 by 3 and minus 3 by 2 and 1. So if you see, is there any changes in first two rows? And second and third row, no change. Coming to the third row and fourth row, so there is a change in the sign. So there is a change from positive to negative. And also coming to the last row, this negative becomes again a positive number, plus 1. So there is again another change. So there are two changes in the signs of the elements of first column. So from this we found out that there are two roots of the characteristic equation, and hence there are two roots on the right half of the S plane. So this is the conclusion. So the answer is B1. So the answer is B1. So coming to the second question, the number of open right half plane poles for this transfer function is, so we have to construct the roots table and find the open poles. So the solution to this equation, to the second problem is, the given characteristic equation is s power 5 plus 2s power 4 plus 3s power 3 plus 6s power 2 plus 5s plus 3 equal to 0. So let us construct the roots table. So here s power 5, s power 4, s power 3, s power 2, s power 1, s power 0. So the coefficient of this one is 1 and this 3 and this 5. So coming to the second row, the coefficient 2, 6, 3. So if you see, for this one we have to, for the third row, the answer is 3 into 2 minus 6 into 1 divided by 2. So 3 into 2 is 6, 6 minus 6 divided by 2 becomes the 0. So it becomes 0, but it is not, we cannot proceed further if it is 0, because the next step here it will become infinite. You will get an answer as infinite because this goes to the denominator. You are going to divide this as coefficient in the next step and it becomes infinite. So don't allow this to be 0. So the solution is, you have to introduce a small positive integer, that is epsilon. So I am going to introduce a small positive number, that which is epsilon, instead of putting 0. So by proceeding further like this, you will get this table like this: 6 epsilon minus 7 divided by epsilon, and this becomes 3 and this becomes 0. And proceeding in the same fashion, we will be getting 7 by 2 minus 3 epsilon divided by 6 epsilon minus 7 by epsilon, and this becomes 3 and this becomes 0. And coming to the next row, this is 3 because the constant is 3, and 0 and 0. So from this, here by putting epsilon, we know that the epsilon is a small positive number. Here we are going to determine the roots and also the number of roots in the right half of S plane. So by limit epsilon tends to 0 for this term. For this term, 6 epsilon minus 7 divided by epsilon, you will be getting minus infinity, because 6 into 0 minus 7 by epsilon. So it is minus 7 by epsilon. So which is nothing but the 7, by replacing epsilon with 0, you will be getting minus infinity. And also apply the limit for this equation: 7 by 2 minus 3 epsilon divided by 6 epsilon minus 7 divided by epsilon. So by applying the limit for this one, you will be getting the answer as 7 by 2. So from the first element, so just concentrate on the first elements of the elements of the first column. So those are these. So this becomes minus infinity, and this one becomes 7 by 2, and this is 3. So if you see the elements of the first column, this is positive because we assumed this to be the positive integer. So from positive there is a sign change here, and also from negative this becomes positive. So there are two sign changes. The sign changes two times. So hence it is concluded that there are two roots of the characteristic equation on the right half of the S plane. So the answer is C. The answer is C. So coming to the third equation, the open loop transfer function of a unity feedback system is this one. So we have to find the K, the range of K for which the system is stable. So for the system to be stable, the elements in the first column, there should not be any sign changes in the elements of the first column. So this is the criteria for the system to be stable. So going to the solution, so the solution is, we know that characteristic equation is given by 1 plus g of s equal to 0. So they have given g of s, and from by substituting in this equation we will be getting the characteristic equation s into s square plus s plus 2 into s plus 3 plus k equal to 0. From this, s power 4 3s cube plus s power 3 plus 3s square plus 2s square plus 6s plus k is equal to 0. By simplifying this, we are getting the characteristic equation as s power 4 plus 4s power 3 plus 5s square plus 6s plus k equal to 0. So applying the roots table, s power 4, s power 3, s power 2, s power 1, s power 0. So the coefficient is s power 4 is 1, s square 5, then constant k. And the second row 4, 6, 0. Third row becomes by multiplying 5 into 4 minus 6 divided by 4. So by simplifying this we will be getting 7 by 2 and this as k and 0. And this one 6 into 7 by 2 minus 4k divided by 7 by 2 will yield you answer 21 minus 4k into 2 by 7. These all will become zeros, and coming to the last row, the constant k. So for this system, for the system to be stable, the first column, check the just concentrate the elements on the first column. This one should be these two elements. So last two rows, the last two rows elements should be greater than 0. That is, k should be greater than 0, as well as 21 minus 4k 2 by 7 should be greater than 0. So by simplifying this one, that is 21 should be greater than 4k. So k should be that is 21 by 4. I'm really sorry. K should be less than 21 by 4. So applying this, combining this one and this one, will be getting 21 by 4. That is, k is less than 21 by 4 but greater than 0. So the answer is A1. This is the answer for the third question.